Let's take a look at the 12.4 worksheet on expected value. So you're going to definitely need your calculator here. We're going to do a lot of multiplication. So number one, it says a sales manager was trying to estimate her company's sales for the third quarter. After meeting with her salespeople, she determined that there was a 50% chance of selling equipment worth $100,000 to college A, a 70% chance of selling $50,000 worth of equipment to college B, 90% chance of making a $150,000 sale to college C, and a 40% chance of selling $300,000 worth of equipment to college D. It says find the expected value of the quarter's sales. So what we're going to do is take each dollar amount and multiply it by the probability of making that sale and add those up. So what we're doing here is we're taking $100,000 and we have a 50% chance of making that sale, plus a $50,000 sale to college B, we have a 70% chance. And then a $150,000 sale to college C, we have a 90% chance. And a $300,000 sale, we have a 40% chance. So, taking out our calculator, I'm going to slide this up high so that I can see it as I enter it in. We just want to type these values in and get our results. So we're going to take 100,000 times it by 0.5 plus, we're going to go 50,000 times it by 0.7 plus 150,000 times that by 0.9 and go one more, 300,000 and times that by 0.4. Hit enter and we should have an expected value of having $340,000 in sales. All right, let's take a look at number 2. Number 2 says, Rita is practicing darts. On this particular dartboard, she can score 20 points or the bullseye, 10 points, 5 points, or 1 point for the other regions. Although Rita doesn't know exactly where her 5 darts will land, she has been a fairly consistent dart player over the years. She figures she can hit the bullseye 30% of the time, the 10-point circle 40% of the time, the 5-point circle 20% of the time, and the 1-point circle 5% of the time. What is the expected value of her score if she throws 10 darts? So what I want to do first here is calculate out the expected value. This will be for like saying what is the average value that, or the average point total I would get for one dart. So as it says here, she's going to get the bullseye 30% of the time. So 30% of the time, she's going to get 20 points. So 20 points times the 0.3. Of the 10-point circle, she's going to hit that 40% of the time. So she'll get 10 points 40% of the time. Then the 5-point circle, she's going to get 20% of the time. And the 1-point circle, she will get 5% of the time. Now, this isn't listed nor necessarily really needed, but just to let you know, if you add up these probabilities, they only add up to 95%. So 5% of the time, she's going to miss the dartboard and get 0 points for it. I'm going to assume that that's no points. Now, it's not necessarily needed because anything times 0 is still 0. So, let's type these into our calculator and get the value. So, clear this out so you can see it. She'll get 20 points 30% of the time. Plus, she'll get 10 points times 40% of the time. Plus, she'll get 5 points, I remember what was that, 20% of the time, times it by 0.2. And then she'll get 1 point 5% of the time. So I multiply those all together, it will give me 11.5 points. So this would be 11.0, was it 11? I apologize. You gotta go back to it was 11.05. Just wanna make sure I write that. So she gets 11.05 points on average per one dart thrown. Okay. So I just want to make sure you know what that value represents. But to answer my question, I'm looking at the next 10 darts. So I'm going to take 11.05 and times it by 10. So when I do that, she should score on average 110.5 points on average for those 10 darts. All right, turn to the back side. A few more expected values. Number 3, love this one. It says a radio station is giving away tickets to a concert. 16% of the tickets that are being given away are from Section A, 24% are from Section B, 32% are from Section C, and 28% are from Section D. Tickets for this concert are priced differently depending on what section they're in. Section A are $35, Section B are $30, Section C is $25, and Section D is $15. You call in and you win one of the tickets. What is the expected value of the ticket? So again, to get your expected value, you're taking the cost of each ticket or the value of each ticket and timesing it by the probability of you winning that ticket. So we're going to start with seat A is $35. There are a total of, if I look here, 16% from Section A. Then Section B is $30. There's a total of 24% from this section. And then Section C is $25. There's a total of 32% of those tickets. And Section D is only a $15 ticket, and 28% of the tickets sold are from that section. So I'm going to type that into my calculator, multiply them up, and get my answer. So the average value of a ticket is $35 times 16 plus $30 times 0.24 plus $25 times 0.32 plus $15 times 0.28. Go ahead and hit enter, and lo and behold, it ends up being that the average value of a ticket is $25. Number 4, okay, says Duncan Delilah Jones is one of the best free throw shooters on her team. Over her career, when Delilah has a chance to shoot 2 free throws, she makes both shots 60% of the time. She makes one shot 30% of the time and misses both 10% of the time. On average, how many points do we expect her score each time she shoots for 2? So here, her expected value, well, if she makes both, she gets 2 points. She does that 60% of the time. She makes both, so she'll get 2 points 60% of the time. She'll get 1 point 30% of the time, and she gets 0 points 10% of the time. Now that last one you wouldn't necessarily have to write, because again, anything times 0 is 0. So if you multiply and add these together, 2 times 0.6 plus 1 times 0.3, if you just trust me, it's 1.5 points on average every time she steps up. Doesn't mean she's going to get 1.5 every single time, it just means that's what her average is. Okay. All right, the last one. Number 5, the lottery one. It says, the table shows a scratch-off lottery game. A says, what is the probability of winning nothing? So here, if you look at your ticket here, you have $5, you got a 30%, $10, 10%, $20, 5%, $250, 1%. So one of the things I'm going to do is I'm going to add up all those probabilities because that would be the probability of winning something. So if I add those all up, I believe I get I can't add correctly, 0.46. So 30%, 40%, 45, 46. So 0.46 is the probability of winning something. So I want the probability of winning nothing. So the probability of winning nothing should equal 1 minus the probability of winning something. Well, I have the probability of winning something right there, so 1 minus 0.46 will equal 0.54. 54% chance, more than half, that I'm not going to win anything. Bummer. Alright, so let's look at B. It says, what is the expected value of one ticket? Alright, so the expected value of one ticket. I win $5 30% of the time. Plus, I win $10 10% of the time. I win $20 5% of the time. And I win $250 1% of the time. So, I'm going to type this into my calculator. So, pull out that calculator again. So, I go 5 times 0.3 plus 10 times 0.1 plus 20 times 0.05 plus, whoops, I did that times there, plus 250 times 0.01. So I get $6. So on average, okay, a ticket will pay out $6. Right? So again, this is on average how much I would expect to win for one ticket. So now, the tickets in the lottery sell for $10 each. Okay? How much money does the lottery expect to make if 10,000 tickets are sold? Okay? So they sell them for $10. Okay? The expected value is $6. So this is my expected value. So I expect to make $4 per ticket. So if I'm making $4 a ticket times my 10,000 tickets, I would expect to make $40,000 on this particular lottery. Not bad. Now you know how the state of Minnesota makes millions of dollars on those scratch-off lottery tickets. All right, that ends that worksheet.